So the friendship paradox basically states that statistically speaking, you are the least popular person in your friend group.
All right, 3, 2, 1. Welcome, everybody. We have finally reached the stage of our podcast where Lee about dies with excitement. Today, we are going to get to the simulation argument, one of the more interesting arguments out there. It's funny because we were just going over the show notes right before we began here, and Lee was so amped up about it that he was going through all the different topics that we're going to discuss, and it was so interesting to me. I was like, hey, we need to start just recording because like otherwise we're going to go through it again. But yeah, Lee, how are you feeling about today's podcast? Excited?
That's pretty much the average podcast. No, I'm obviously very excited about this one because I think this, even though it gets outside of what my expertise, if you would call it that, is in physics. But this really gets into philosophy, which is something I'm obviously interested in. And but I think it's something that we all think about, sort of the concept of being, and then simulations. You know, I think it's sort of on the outskirts of people's thinking, but it's something that I've been fascinated with for probably about a decade. So I'm very, very excited to talk about this.
Yep. Well, before we get into it, as always, if you're watching and you have not subscribed to our channel or to Lee's channel, please do. Additionally, you got to make sure to smash the like button.
You have to smash that like button. You can't just press it normally. We know that.
Maybe in the future, they'll start installing keyboards with a like button on it where you just click it and you can actually smash the like button. That would be a lot more helpful.
You know, that would be a good use of our time. Make an animation where the like button just gets shattered, right? And then you get that pleasure of like, oh, I smashed it, you know?
Yeah, very tactile. That would help out a lot.
Yeah.
And yeah, as always, leave comments on the videos. If you have any questions, you know, constructive criticisms, praise, anything you want. With that in mind, all right, without any further ado, let's lay the groundwork a bit here and let's go all the way back to the beginning. Physics. We started this podcast.
Heard of it.
Because Lee is our resident expert. At least you're more of an expert than me. How about that?
I will take that, Josh.
Okay.
That's an accurate description.
Relatively speaking, if you and I were the only people that existed, you would be the expert in physics.
Yes.
Okay. All right. Cool.
I'll take that.
So we've discussed many topics so far, but let's go back to the beginning here. What is the point, Lee, of studying physics? Why have modern society for the last couple hundred years taken such an interest in the study of physics?
Yeah, so physics is the branch of science that deals with like the structure of the universe, the structure of matter, and how these fundamental forces in the universe interact. You know, that's sort of like the technical definition. The broad definition is how do things work? You know, if you go to sociology, you think about, oh, this is how human beings interact. Human beings interact with each other. You're like, oh, okay. Well, how does a human being work, right? That's the study of biology. And you're like, oh, well, they're composed of these molecules. And it's like, well, how do these molecules interact? It's like, oh, that's chemistry. And it's like, well, how do these atoms interact? It's like, that's physics, right? Mm-hmm. So, you know, it's really just at a fundamental level, like we want to figure out what are the building blocks and like how do they interact with each other. And so just in broad speaking, I think this goes into the study of science in general. We are very curious by nature, right? It's not 100% exclusive to Homo sapiens. Obviously, cats are very curious, but like our curiosity is not only in like observing things. We want to come up with a system and a reproducibility, right? We want to know that if I'm going to step down from this stair, I'm going to hit the stair below it and not float up and hit the ceiling. And so that is really just why we are driven to study this. Is we want to look with our eyes and see something, and then we want to come up with some prediction. Obviously, as advances in science have happened, we don't really truly observe them with our eyes anymore. Particle detectors are our eyes, right? We smash atoms together and then we can look on a screen, but what we're looking at on a screen is some oscilloscope which is telling us that these two massive particles have collided and this is what happened. But it's still the observation of it. We're trying to figure out, as we observe things, how the world works by those observations.
So physics, study of the fundamental forces of the universe and the particles of the universe. And then at some level, though, when you're studying that for long enough, and we get to, like we did last episode with quantum physics, things start to get, the smaller you go, they get a little wonky. And so you start to, that's, I think, where a natural sort of, philosophy like comes on into the room. Is like, hey, I can help out a little bit here, because things are getting a little crazy down there at the microscopic level.
Yeah, exactly. Right. As you really dig into how the universe interacts, it becomes really weird. Quantum mechanics one great description is that quantum mechanics is weird, right? We talked about this a little bit last time. Like, how on earth could a particle know that you're watching it, right? It's going to just be like, hey, I'm just going to be, you're watching me? No, I'm going to go left. But if you don't know, I'm going to go left and right? Like, that just seems weird. And so, that in itself is very weird. And so it causes us to question the nature of reality. And we ended last podcast with, the great physicist, Jim Gates, saying that he found some really weird things when he was investigating particle physics, that he found some peculiarities.
I knew you were going to do that. I'm not even going to say it. Keep going.
I still don't know if I pronounced it right, but he found some peculiarities when he was studying particle physics, in that there was, in a sense, some sort of error correcting mechanism there that like helped to fix what was going on at a fundamental level. And that's a really weird thing. It does not seem natural, and doesn't seem natural to me.
Yes, the error correcting. So in terms of error correcting itself, I mean, I think that's a good segue to setting up some more context for the simulation theory. You already touched upon this briefly with when we're observing quantum physics, the fact that particles act differently when we observe them versus not observing them. It's a very small step from there to actually questioning whether we're observing them correctly at all, right? So the observation of reality itself, how do we know, for instance, that what we're observing about reality is the correct way to observe things about reality? Yeah.
So I'll start that off with proposing something that's called the dream argument. It's probably something that we are all intimately familiar with, a dream state and reality. Most people would assume those as inherently distinct. I'm either dreaming or I'm in reality. Philosophers love to pose questions like this. So a very common thing when I took a philosophy class was our teacher said, "Prove to me that I am not dreaming." And as with many philosophical propositions, we were doomed to fail, because it's very difficult to prove to someone that you are not dreaming for a number of assumptions that you might list out. We talked about this a little bit ahead of time. There was a very famous philosopher, David Hume, who created a number of different works of art. One of them was the essay concerning human understanding, in which he basically discussed the idea of like absolute necessity in our existence. I'm not going to go into that one because, frankly, I did never read it. Josh did. Josh could probably explain it better than I could.
That'll be on our David Hume podcast later on.
Yes, we'll do that in podcast season 2. The other is that, one of the assumptions we're making is that reality can be absolutely compartmentalized. And that is something we've talked about, and honestly, something in discussing quantum mechanics, we know that it can't be. One of the things that reality is 100% dependent on is the state of the observer, right? I can't tell you whether you are dreaming because I experience reality differently than you do. And it's almost impossible for me to experience it in the same way that you do. And so we know that how the universe gets observed is 100% dependent on the observer. We talked about this a little bit. If you're going close to a black hole, if you were traveling close to a black hole and I was farther from it, you and I might meet and you would have only seen time as like seconds pass by and it would have been a decade for me. So even time, space, all of these things are dependent on the observer. The other thing that's really flawed in trying to think about the dream argument is that there is this binary difference between dreaming and reality. And anyone who's experienced lucid dreaming or anyone who has had this sense that like in their dream they recognize that they're dreaming, but why can't you wake up? I mentioned this when I was in grad school. I had many times which I would stay up way too late, many hours at a time, and I would have times at which I would wake up and recognize my body, but I couldn't wake up until I had jolted myself out of this dream state. And so that was my first experience with like, maybe this is a spectrum between dream and reality. And
was that kind of like sleep paralysis where you could observe your body, but you couldn't move at all? Okay. Yeah.
Yeah. And it's not unique. People experience this. Lucid dreaming is something where people actually have control over their dreams. We observe a reality is that like right now, I can move my hand, I can move this microphone, I can pick up this glass of water, and all of that is fine. In a dream, you maybe don't have as much control. Reality is sort of thrown at you and you are just experiencing it as if you were watching a movie.
Yeah.
But maybe
can I throw a crazy theory at you that I just thought of? So like you said, everything in the universe is dependent upon the observer, right? So if we're in waking reality right now, it's dependent on my perception is dependent upon me, the observer. Your perception is dependent upon you. What if when you're dreaming, you're no longer the observer? Like someone else becomes the observer. Maybe that's why it's so strange, or like the perception's so off. Things get wonky.
Josh, I think what this podcast is going to teach us is that is not very crazy of an idea, right?
Okay. Yeah.
I think, yeah. And so again, what anyone who's experienced this, what should become evident is that the difference between reality, our idea that reality is this 100% concrete thing is not an accurate description. Reality is only our perception of it, and our perception of it is very flawed. And so, maybe even just contend that like it's only 99.5% accurate.
Sure.
Guess what? You have tens of millions of experiences in your life. That means a couple of them aren't going to actually happen. Right?
Yeah, I mean, isn't that a crazy thing to think about? I was joking before we began that we need like a trigger warning of like existential crisis alert, because, for instance, one cool thing to think, maybe not cool, I think it's cool, but one cool thing to think about is even if 5 of those 10 million experiences you've experienced aren't real, what if they're the 5 most important experiences you had in your life, right? Like it depends on the importance of the experience too.
Yeah, I mean, it also probably there's a complete psychological aspect to this. If it's something very critical, what if I thought I got married, but I actually didn't? But I shaped my entire existence on the fact that I did. Maybe there's not a wedding ring on my finger right now. Maybe all of this is me just telling my brain and deluding myself to think this. I think that's a small probability, but again, this is what the whole part in the dream argument is to just it opens the door to say that reality is not 100% accurate, right? And all it has to do is open the door, and then once you do that, it brings you into an entire realm of physics and philosophy called observer selection bias, and this is basically like, what sort of biases do we have in observing the world? And I think this kind of gets back to your initial question. So if you think about the dream argument, now we're thinking about, well, what sort of biases do I have? we know that we have biases, right? We select our friends in terms of people that we understand really well. We eat foods that we've usually eaten before that we like, and we usually drive roads that we've driven before. So there's always sort of selection biases. Even thinking about the concept of science itself, there is at a meta level, we only study science that we think is worth investigating. So there's already bias there. We're not going to study things that we don't think are interesting. And we don't even have to go down the path of research that gets funded. Even the research that we want to explore is only things that us as humans, we think is interesting.
Yeah, I mean, that's a fascinating thought there too, because of the vast range of possibilities of things that you could study as a physicist. That already probably precludes a near infinite amount of other things that we could have studied, but we just don't even think are important or would even think about studying in that case. Okay, so I mean, going off of that, we came across in some of our, well, maybe my background study might have already known this, but some fun paradoxes. As usual, it's nice to bring up a paradox here. But let me ask you a question, Lee. So would you say, theoretically speaking, if you considered you and all of your friends, your friend group, would you say that you're the most popular person in your friend group?
I would say yes, almost definitively. I think I'm the most popular person in my friend group.
Okay, all right. So for the purpose of the argument, I won't dispute that. So,
and my ego?
Yeah, exactly. But from what I read and from what you told me, if you think that you're the most popular person in your friend group, you're almost certainly wrong, statistically speaking. Now, why might that be the case, Lee? Not you personally, of course. I'm just saying in general, you might be correct.
Yeah, it is. It's very counterintuitive. But as Josh has mentioned, this is something called the friendship paradox, and something this podcast is going to be riddled with more than any other is references. So we'll reference this in the comments line, either of Josh's podcast or mine. So the friendship paradox basically states that statistically speaking, you are the least popular person in your friend group. Now,
it's the exact opposite, huh?
It's the exact opposite, right? Now, this is, as many times paradoxes state, they're always kind of dark, right? We've talked a lot about like the grandfather paradox where you had to go back and kill your grandfather. Now we're telling you that like you are not very popular.
Not only did you have to go kill your grandfather, you're not popular as well. Yeah, it's getting worse and worse.
Now, popularity is basically the amount of friends that you have. The person that I am friends with is less popular than me. And so as you look at the hierarchical structure of how these friend groups are structured, they're dominated by people, by the very few percent of people who have a massive, massive friend group. And statistically speaking, most of the people lie in they're only friends with those few people who are very popular.
Mm-hmm.
So again, it's very counterintuitive, either psychologically speaking, or even, sometimes the mathematics of it don't make sense, but the mathematics of it are sound. I've actually done it before. It has to do with Cauchy integrals and things like that most people don't concern themselves with, but I proved this to myself in graduate school. And a lot of this goes into designing social networks. This is a lot of how Facebook got very popular, is designing how people interact with each other. So anyway, that is the friendship paradox.
And that just, again, getting back to what we were just discussing, that is an excellent illustration of a bias that you may hold. Again, you don't even have to think you're the most popular person in your group, but you might, I would think most people would think like, are you above average popularity, in your friend group? Most people would say yes. Would anybody say you're the least popular? Probably not, although statistically that's the most likely thing to be correct. So how does that
or not even least popular, but statistically speaking, it's like by me saying that I am the most popular, then I'm saying that all of my friends are less popular, right?
Okay.
I'm not saying you're the least. I'm just saying that I am higher and you are less. But again, even if you think about it, like not everybody can be the highest, and I think a lot of this is, you see this sort of bias also in parents, right? Oh, my kid's the smartest kid, right? Like there's only one kid in the world who's the smartest kid in the world, but there's this bias that you've created this thing that is better than you, and you've helped it to learn from your mistakes. But again, there's biases all over the place. So,
Yeah, so that stretches through any kind of field of study. But in terms of getting back to observing the universe, how might the biases that we use or fall into affect us with our observations of the universe?
well, actually, I'm going to throw this back at you
Uh-oh.
because I know you did your research ahead of
Oh
time.
yeah,
So,
sure.
Josh, I know that in World War II, for instance,
Mm.
the military was trying to figure out how to improve planes, right? And so, I'm just a captain. I'm working in a repair shop at a military base, and I see a plane come back, and I'm like, man, there's a lot of bullet holes on the edges of the wings. I need to put some more armor plating on the edges of those wings. But Josh, you are a general in this Air Force, and you're telling me no. What if I missed, and what sort of bias do I have that I'm trying to repair where the bullet holes are?
Right. So on the surface, it seems like a logical step to take, right? Where you want to repair the wings because the wings have taken damage from bullets, and you think that's the most logical place to strengthen in order to prevent future planes being shot down. However, the problem is that we're not actually observing any planes that have been shot down. All these planes are ones that made it back safely. So if your wings have been damaged by bullets, well, it doesn't really matter because what we're aiming for is we need to find ways to prevent planes from going down, and we have no planes that went down. So the conclusion there, again, just like with the popular person, somewhat counterintuitively, is that statistically speaking, if you want to prevent or strengthen all the planes in that Air Force and make sure that they don't go down, you put more armor on the spots that didn't take any bullet damage. Now, that sounds strange. All right, Captain Lee, why? Any idea why that might make sense, though?
Yeah, I think this goes. There's an underlying concept here that is they call it the Boltzmann brain, and I won't go into the rationale of why, but Boltzmann was a great physicist and scientist. But basically, it's that the problem arises when we start to experience the world, and we use it to construct our best theory of how the world operates, but as educated sapiens, we quickly start to realize that this theory predicts that our sense data are unreliable. So we have created a theory, and that theory tells us that our senses are unreliable, which means that theory is unreliable itself. And so that in itself maybe is paradoxical, and they call that the Boltzmann brain. And as I said, Josh and I will reference that. But again, this all goes into us observing the world and trying to understand what it's given us, and not even at first glance realizing the biases, even at a very meta level, right? We're only looking for things that we think are interesting, and we're not looking at the things that are uninteresting. But maybe that's what dictates how the world works.
Yeah, and I mean, one big bias that I think is the next kind of main segment of our episode is we just take for granted, for instance, that we as human beings can observe things about the universe and can agree upon that, right? Or even again, that's already, in my opinion, that's already kind of a couple steps down the line. If we go back even further, it's like the very fact that we could observe anything about the universe really is kind of weird if you think about it, because it seems like if we're just a part of the universe, we wouldn't be able to step outside of the universe to observe it, if that makes sense. But we all agree on that. So then let me flip it around on you one more time. Why, for instance, there would the universe be able to create beings that could then observe the thing that created it?
That's a very good philosophical question, right? That question itself, like, how can the universe create beings that can observe the universe which created those beings?
Yeah, that can step outside the creation itself and observe it again.
So this goes into something that I would assume most people haven't heard of, because I've asked my friend group and most of them haven't heard it. And we know that my friend group is not.
It's most of the world, actually, I think.
Yeah, right.
Yeah.
So this goes into something called the Anthropic Principle. And the Anthropic Principle basically attempts to determine how statistically probable our observations of the universe actually are, given the fact that we only exist in that universe to start with. So if that's hard to wrap your head around, I'll just boil down. There's many anthropic principles. They usually boil down into two categories: weak and strong. But essentially what the anthropic principle says is that the universe exists in the state that it does because we observe it in the state that it is in. I'll repeat that. The universe exists in this special state that we are able to be brought up as carbon life forms and observe everything because it's in that state. Now, if this sounds like some sort of reverse post office logic, it kind of is. It doesn't really make sense to
some circular logic a bit there.
Circular logic there. So, it's probably helpful to go through the weak and strong anthropic principle. So the weak anthropic principle essentially state like what physicists battle with is like when you look at the fundamental constants of the universe, there's things like the fine structure constant, Heisenberg's constant. There's a lot of different constants that we call them fundamental constants. If any of those constants was off by even just a little bit, the universe might have imploded on itself, or the universe would only be made of hydrogen and helium and we would never exist. So how is it that they are just that way? And the weak anthropic principle states that it exists that way as a result of survivorship bias, right? Just as you talked about, Josh, with those planes coming back from World War II, we're looking at it saying like, oh, we should look at these and say, oh, well, these are the ones that survived, so these are the ones that we're observing. The universe that we are observing is the one that survived. And there's got many implications. You could certainly take it to quantum mechanics and say, hey, remember quantum mechanics presented us with this multiverse, right? That every decision we made caused a parallel universe. We happen to be living in a universe that made it so that carbon life forms could exist. But there's many branches in the multiverse where they don't. There's just a bunch of hydrogen helium atoms in the universe, and they're not doing anything. Or maybe they're having a big party. I don't know. So that's essentially the weak anthropic principle is stating that it's a result of survivor bias. And that's, again, just has to do with statistical population of universes to select from. However, there is a part of the weak anthropic principle that does not require it to be part of the multiverse. You could even think about the number of planets in our universe, right? One of them is bound to produce life forms in this Goldilocks zone, as it's called, where sapiens, or where organisms can evolve to sapiens who can observe it and question its reality.
Okay. So go ahead.
That's the weak. I was just going to say the strong anthropic principle, which is one I'm not quite as familiar with because it's not used as much in the literature that I look in, basically states that the universe is compelled to have conscious and sapient life forms emerge to observe it. Again, that was, I think, brought by Tipler and Barrow were the two. I think it was a philosopher and a scientist who brought that argument that if you have a universe that has observable quantities, it is compelled to have an organism which is going to be able to observe those quantities, because otherwise those quantities would not be observable. These things that they really sort of boggle our mind. They do seem like circular logic, but these are the principles of which we're founded on.
Right. So based off that principle, I guess if we went back to quantum physics real quick, the particles themselves exist only are compelled to exist for us to observe them, or we were created to observe the particles, something like that? Compelled to observe the particles?
Josh, I'll be honest, this is a little bit outside of my wheelhouse of understanding. It's a lot outside of my wheelhouse of understanding. My wheelhouse of comprehension, I would say I can comprehend why that is the case. Yes, the particles have particular characteristics which we can observe, like position and velocity and spin, because at some point there was going to be some method of detecting those, and they were going to interact. I mean, the fundamental physics of the universe caused them to interact in those capacities, but at some point they are going to evolve into a state at which something will be able to observe the totality of the universe, I think, is what the strong anthropic principle says.
Yeah, that one, in my novice opinion, is one small step away from religion at that point, because it's like the universe was created or compelled to create creatures to observe it. Again, if you read any sort of ancient text, it's pretty similar. It's like God created the universe such that we could enjoy it, or that we could observe it and see all the wonderful things that he made, or something like that. It's pretty similar. It's kind of interesting.
Yeah, I think this is where, I think for millennia there has been this battle between science and religion, and I think this is where you look, and maybe it's not a great analogy, but they say that the line between genius and insanity is very thin. This is like they're a lot closer. Like you see two battling people, and it's like you guys are basically, you don't know how close you actually are, right? Like we're talking about the same thing, just from different perspectives.
Yeah, it's almost like two twins fighting over who's better looking, It's like, well, you guys are kind of this. No, they're not exactly the same, but they're similar. Maybe fraternal twins. All right. Fascinating. Okay, so this, again, we're getting to simulation. I promise everybody. We're setting the stage here. So Lee, how does this? Okay, so we're still about one step away from simulation theory here, because so far we've talked about observation bias. We've talked about, it's hard to know it might be impossible actually to know with 100% certainty what reality is versus a dream, for instance.
Yeah, that's what we're postulating, that the world as it exists is not 100% accurate as you observe it. And if you don't acknowledge that, I would say you're somewhat delusional, right? I mean, I am not 100% certain that I'm looking out the window and seeing flowers. I'm pretty sure, but maybe I'm hallucinating. Maybe I'm dreaming, right? Maybe actually I'm recalling a memory that I had before. We've all had that experience where you've been arguing with a friend. You're like, no, we went to this together. And it's like, no, man, we didn't. One of you is wrong and one of you is right. And if that's happened more than 1% of the time, then reality is not what you think it is. That's what we're trying to get to.
Right. And there's different levels of probability there, right? So you can probably safely assume the window outside or the outside is real, unless, maybe you're locked away and it's a simulation, but I'm getting ahead of myself there. And then there's other things that you can maybe have less certainty about, like once you die, where do you go? Well, you could say nothing happens, but you might have less probability of saying that than what you see outside as a flower. Different levels of probability in that case.
I would love to talk about that, but in the interest of time, like thinking about the afterlife, that's great survivorship bias, right? You never know. You will never know the things that survive after, so we can only postulate at this point. But anyway, let's keep moving on, because that's another rabbit hole, and we've probably got too many open at the point.
Yeah, we've got so many rabbit holes, we're going to sprain our ankle tripping over them. Okay, so one final piece of the puzzle here. If we bring in humans and our observation of the universe, and then our own sort of, you could think of it like a creation ourselves, right? If the universe was compelled to create us, we've also rather recently in our timeline started creating systems of knowledge and intelligence, artificial intelligence, that in many ways, does a decent amount of what humans can do. There's still, of course, things that don't work out pretty well. But it's interesting how there's almost like layers there. You got the universe creates us, and then we start creating this artificial intelligence, which may eventually be able to observe us. I don't know, Lee, how close do you think we are to that?
Yeah, so I think it's important we use AI in we use AI as sort of it's very conversational now, and the colloquial use of AI, it has gotten to the point where I think we need to understand where we're at on the spectrum. So the spectrum, I would say, goes from weak AI to strong AI. And strong AI at some point is going to reach what most scientists what they classify as artificial general intelligence. This is the point at which a computer can learn or understand any human task. This is what they call the singularity, right? This is where this podcast all started, right? The point at which a computer can learn and understand any possible human, in every iteration of human emotions and tasks, is the point at which a strong AI has become an artificial general intelligence. Weak AIs, as anyone knows, is Siri, it's Alexa, it's Google Assistant. Sometimes I wonder how far off we are from artificial general intelligence when I ask, Alexa, something that is the most trivial thing in the entire world multiple times and cannot answer it. And I think, it's not even like asking a child, because at some point a child will say, I don't understand, or a child will give you some context.
And a child can learn too, right?
Yeah,
Or
and a
can
child
acquire.
can learn like, oh, this is what you meant by this. A weak AI, they're very narrow. And so you're a chess player, Josh. You've been playing a lot of chess. A great example of a narrow but really amazing AI was Deep Blue. Deep Blue was the computer that was developed initially, I think, at Livermore Labs. It faced Gary Kasparov, who was the best chess player in the world in the 90s. And he faced him. And what it did is they created an AI which could go through every iteration and look at how the human was interacting and say, I'm going to do the best iteration of this, and I'm going to try to outsmart him.
It's like game theory to an extreme.
Yeah, game theory. Yeah. The first Deep Blue won a game against him, but I think ultimately he won the match. And then they made one called Deeper Blue, right? Yeah, they optimized it a little bit, and then it beat him. I mean, it sounds impressive. Like at the time, it was monumental. Oh my gosh, a computer beat a human. Look at how smart they are. That computer was not very smart. That computer could not order groceries for you. That system, that multi-million-dollar system, couldn't do anything but beat people in chess.
Yeah, that computer would not last very long in the real world, let's just say.
Yeah. If you talk to that computer couldn't fool you into thinking it was human. And so, when we think about that, it's very important to point out, what is the test? How do we test to see where we are in the spectrum? And there's a bunch of brilliant people, Ray Kurzweil, Nick Bostrom, have come up with estimates of like, what are the benchmarks and how do we rank intelligence or super intelligence along the way? The Turing test, Alan Turing in the 50s came up with like a series of questions in which you could ask a computer. Essentially they were yes or no questions, right? But through this, you could determine, is this a human or a computer? And the Turing test is, if a computer can make it through it and pass it, you've got an artificial intelligence. That's probably limited in some scope, right? Like you would want to ask, I would guess, more qualitative question. What's your favorite experience, right? Like what do you think is most enjoyable? Like, can you ask a computer something that requires a lot of context that they have to do many different interpretations on, and then to give you an answer that you wouldn't know the difference between?
Right. Or like you ask like a quick follow-up question that may like throw them off guard or something to try and confuse them.
Yeah.
Something like that. Yeah.
So that's something we've all been able, like no one has, not even kids are fooled into thinking that Alexa is a real person, right? Or that Google Assistant is a real person. it's getting there, but all of those assistants are just a series of very narrow intelligences, and they're just going through a series of protocols. True artificial intelligence is something where, you may ask a computer a question, and the computer would say, I don't feel like answering that. Right? Like
They should have done that from the very beginning. We could have achieved artificial intelligence by just saying, act like a teenager. I don't want to answer that. And then we would have been finished.
Yeah. Or like, you could be asking, maybe you have a artificial general intelligence, you ask a question, and then maybe the follow-up question from the computer is, I wonder if you're asking this, have you ever had any childhood trauma that's led to this, right? And then they ask you questions that's like, oh gosh, wow, like,
yeah,
very insightful. Now I don't want to ask you any more questions, right? So this is the concept of artificial intelligence. We will put a link to the graph that Kurzweil and Bostrom put together and how far we are away from artificial general intelligence. Seems like it's about 100 years. And, one thing before getting into the simulation argument, maybe ties into religion, is that can you truly simulate a human being in a computer program? I'm certain that there's a ton of arguments saying that, like, oh, you can't because of this. You have to go into it thinking that, like, is our human decisions just a series of neural interactions?
Mm-hmm.
If the answer to that is yes, then those are just that's something finite. You could then at some point, all you have to do is simulate every single neural connection in the entire human brain, which maybe it takes a computer the size of the world to do that, but then you could simulate a human being. If your assumption is that, like, oh, you can't, like, it's more than that, there's something that, like, can't be quantized, then that's a different argument, and I don't know how to really approach that.
Yeah, because that gets back to the observer bias we mentioned before. Like, it's a huge yes no. Like, I think either way, you should probably still try and simulate all the neurons. But I mean, I guess one final point I'd have there about general intelligence, it seems one big problem that I can see would be that so far artificial intelligence, like the attempts to improve it and increase it, is merely to sort of equip that computer or that system with the ability to know a bunch of stuff, right? So like Watson with Jeopardy, or the computer for chess, or any artificial intelligence. It's basically just to know everything. And once you know everything, all the probability of everything, then you could simulate being a human. But the problem is humans don't know everything, and yet we're already human. So it's like, how do you bridge the gap by going way over and knowing everything and then coming back to being human? Or is there another way of becoming, or of emulating a human, I guess?
Yeah, I mean, I think that's true. Artificial general intelligence again, it's that ability to learn. It's them saying,
yeah,
it's you asking a computer and saying, who is Picasso? And the computer saying, I don't know. Is he a person? Yeah. And you say, yes. It's like, oh, what does he do? Right. Like, you may say that to somebody. You may be surprised when a human being says they don't know who Picasso is, but if you can have an organic interaction, and then they'll say, oh, that's really interesting. Yeah, no, the painter I know is, this person. For some reason, I can't think of another painter right now.
Monet, Van Gogh.
Yeah, right.
Like
yeah. So they'd say, oh, no, I like Monet. So like that's an organic interaction. So I think you're right that, like, a AGI does not need to know everything. An AGI needs to carry on a conversation as we do now. So it's okay for an AGI to answer, I don't know, right? Like, just as it's okay for a human to say, I don't know.
Or I mean, even more realistic might be for the AGI to lie, right? Like, we've mentioned this before the podcast, but I think one of the best examples of an AI was HAL in 2001: A Space Odyssey, because he's basically this perfect computer that can do anything, has never made a mistake ever. And then once, again, I guess it's up to interpretation, but once he starts to realize that his mortality, or he might be put to an end, he really he just starts lying. He's never done it before. He starts making mistakes on purpose so that he can preserve himself, which is pretty human. I mean, that's actually really human. That's what humans do.
Self-preservation. Yeah.
Yeah. Yeah. So it would be interesting to create artificial intelligence such that it was a human. And that's what all the sci-fi movies are. Basically, they end up like, hey, like, I don't want to do your bidding. I'm not going to be like a selfless human being. Most human beings aren't completely selfless. No human being is. So yeah, that's where all the sci-fi movies come into play in that case.
Yeah, I think, again, before we get into the actual simulation argument, I think, our fear of AI is mostly driven not by artificial general intelligence. It's viewed by like the danger of narrow AI, right? I tell you, Josh, I need you have one goal. You need to come in and make sure that there is no mess in this entire office. Well, I mean, you as a human might understand that I want to keep everything. I want to keep my house. A computer might say, oh, well, actually, if I just burn down the entire house and clear the entire thing, there would be no mess. Or I could sell everything off and there would be no mess. So I think that's the danger we find in like creating something very narrow that requires context. That's where our fear is. Our hope is that we could get to AGI and artificial general intelligence will have context and saying, hey, you're a sentient being, I'm a sentient being. I don't see much difference in the fact that I'm housed in a computer and you're housed in a biological body. When you asked me to optimize food shortage, I'm going to try to find a way to keep all the humans alive, whereas a narrow AI would say, hey, the easiest way to make sure there's no hunger is to just kill all the humans.
Yeah.
Right.
Yeah.
Like I think that's the when we look at like our fear of it, we're fearing a narrow-minded AI and not yeah.
Although I will say, I think this will be the last thing I mentioned, and we can move on. But the main problem there will still be if we try and create general artificial intelligence that mimics humans to a perfect degree, we're going to have to still get rid of human self-destructive tendency, because that's just like a huge aspect of humanity that, is a desire to dominate, basically. I mean, a desire to control things, a lot of negatives to it. So if we make artificial intelligence just like humans, they're going to have just as much negativity as humans do, I assume.
Yeah. Well, I mean, you could make the argument that once we reach AGI, that is the next step, and they will evolve faster than us, and they will probably evolve faster. We think about it in terms of intelligence. What if they evolve faster in empathy and say, oh, wow, so these things are like primates, right? We don't go out of our way to kill all of the ants in the world, even though maybe sometimes I do because they invade my mailbox for some reason. But like primates, right? Like we don't think to exterminate the primates, even though we think, oh God, look how aggressive they are sometimes. Like maybe an AI advances much more in empathy and sees like maybe that's almost to me that's maybe even more fearful. It's like they view us like primates. It's like, oh yeah, just let them keep their little plant, like their thing on the planet. Like just they're very volatile, right? They're very dangerous. Let's like keep them in their cage, right? Their cage is this planet. Let's not let them leave this planet, right? Let's let them evolve a little more until they're ready and they have enough empathy as much as us, right?
Yeah.
Like maybe that's the next step in evolution.
I mean, that's an excellent segue here, because it would almost be like, let's encase them with just enough, sort of mysteriousness or fog such that they never are able to escape. Because if they do escape, like they're just ridiculous and crazy and violent. So let's just keep them in their sandbox. So speaking of that, how might that relate to the simulation argument here, Lee?
All right. So
here we are.
Everybody's waited. I've waited. This is the 6th episode. This is where this all started. I told Josh I was more fascinated with this than everything. So the simulation argument as postulated by Nick Bostrom, and not to be confused with the simulation hypothesis or the simulation theory, the simulation argument is merely a conjecture by a philosopher named Nick Bostrom, where he just postulates that we live in one of 3 different propositions or universes or scenarios. And we preface it by defining technological maturity as the point at which we can simulate consciousness in a computer. So let's define that first. Technological maturity is the point at which we have enough processing power that we can simulate a conscious being in a computer. That itself probably it might rattle some people. Is like, wait, when I play a video game, my Fortnite character doesn't think he's alive. My Fortnite character is just me pressing buttons. And when you play Sims, right, or some sort of simulation game, like, you don't think that simulation actually thinks it's alive, right? It's a computer. When you turn it on, you turn it off. It's not any difference. But what if you created a conscious being, this artificial general intelligence that could talk back to you and to have feelings? And when you told it you were going to turn it off, it's like, wait, you're going to kill me? Like, would you have some moral repercussions from that? So anyway, that's technological maturity. The point in time at which we have enough processing power at which we can completely simulate a conscious being. So the three universes that we possibly live in. The first one is, quite sadly, and this does seem to be a theme, we go extinct before we reach that point. That is certainly a possibility. Like, if we think it's going to be in 100 years, the Earth goes extinct, we get hit by an asteroid or something else. We create this molecular nanotechnology that accidentally destroys the planet, whatever it is. So that's the first universe.
Would it also include, as soon as we do achieve that, the artificial intelligence just kills us? Would that also be included in that first proposition?
No, the first proposition is that we never. Well, when I say we, there is actually interesting subtone here. We is not just Homo sapiens on the planet Earth. We is every sentient species that exists in the entire universe in which we live in right now.
Okay.
And hate to say quantum mechanically, maybe even some of the parallel universes, but let's just stay with this universe. So of all the sentient species, all the sentient species go extinct before we can recreate ourselves.
Okay.
The second possibility is that before we get to technological maturity, we decide that we're not interested in simulating conscious beings. For whatever reasons, maybe it's moral reasons, maybe there's something more interesting, right? Maybe we have the power to make worlds and we decide that's more interesting. So that's the second possibility is we're going to live through this. We're not going to go extinct, but we're going to lose interest. Right now, it seems like that's all the rage is let's create an AGI. Maybe by that point, it's kind of like now, it's oh, let's create the fastest car. It's nobody cares about a fast car. People just want to be able to look at their computer while, they want an autonomous vehicle. They don't want to drive anymore.
And in order for this proposition to be true, it still includes every single other.
Single sentient species has to collectively determine that because if one does, then we don't live in that world. So it's right. Every sentient species collectively has to decide that we don't want to pursue that. The third is obviously that we are going to live long enough and we are going to decide to simulate sentient species in a computer. The third is actually one of the very interesting things about the third argument is that the third argument, when you start thinking about it, is at some point we are going to simulate sapient species. And a lot of times they call these ancestor simulations. So there are a variety of reasons why you would want to simulate a species. Mm-hmm. So maybe you're planning on having kids and you think, okay, I have all of these CRISPR edits. For those of you not familiar with CRISPR, we'll add a CRISPR link in here. I want to do genetic editing. So I have right now, even to this day, people have the ability to do genetic editing on their children. In 50 years, maybe you can edit every single gene. You're like, I want to edit a gene so that my child is the happiest as measured by these quantities. and somebody says, okay, well, what you need to do is you need to start simulating, you need to start simulating your family from their first branch of genetic code. And so you need to simulate them from 200 years ago. So you need to start that simulation. You need to start simulating your ancestors, and then you're going to simulate 100 of them. And we're going to look at the ones in which your child is the happiest. Or maybe you want to simulate your ancestors because we're always, as a species, very fascinated with the past. We want to simulate, like, why did they make this decision, right? Let's like, there's a common thing that I hear from history is written by the victors. Let's simulate what happened and let's see if we can figure out what actually happened, right? Why did Rome fall? Why did all these things happen in history? So these are called ancestor simulations. And so if you assume that those are happening, everyone on the planet's going to want to run a simulation. And funny enough, at some point, those simulations are going to reach technological maturity, and those simulations are going to run their own simulations. This is going to require processing power, but given Moore's curve and the fact and the rate at which we increase processing power and the verge of quantum computing, it's only a matter of time until simulations can run simulations. So guess what? There's only one Josh and one Lee that live in a biological being, that live in a biological body. But there's thousands or millions or 10 to the 23rd Joshuas and Lees in the simulation. So then mathematically speaking, the third proposition boils down to the fact that you actually are living in a simulation. It's very unlikely that you are the biological being. If you assert that at some point we are going to live long enough to simulate ourselves and decide to do so, then we are already living in a simulation. And that's what Bostrom's paper, 20 years ago, basically boiled it down to. Is like, if you look at it mathematically, there's probably less than a 50% chance that we're living in a simulation, based on his calculations, but it's not infinitesimal, right? That third argument stands very strong. So yeah, I'll stop there and let you ask follow-up questions, because to me, that's mind-blowing.
Yeah, I mean, the last proposition while you're describing that reminded me, that's basically, again, a perfect analogy to the friendship paradox that we talked about earlier, right? So if you ask if you're the most popular friend in your group, you may say yes, but it's much more probable that you're not. And same here, right? You would think, oh, if the simulation is possible, then obviously your first instinct is to say, well, cool, we can do it. Not to say, oh, wait, but we might actually be in a simulation.
Yeah. And then again, the dream paradox. Josh, prove to me that you're real. Prove to me that you are a biological being and not something that is perfectly simulated by a computer. If the dream if the dream hypothesis holds that you can't prove that you're in a dream, you also can't prove that you're living in a simulation.
Right. Do you remember how long ago? Let's walk through your fascination with this. Do you remember like the first time you read it, or like when it really took hold on you?
Yeah. So Bostrom published the simulation.
It's pretty old, 2003 from what I see here.
2003. Yeah, you're absolutely right.
Yeah.
Yes, 2000. I couldn't remember when it was. Yes, 2003. I think I first came across it in graduate school. One of the other graduate students sent it to me. We were talking about computing power. So at national labs, we have these supercomputers that take. I needed to run a simulation on 5 picoseconds worth of interactions in a plasma the size of the very finest tip of a fine tip pen for 5 picoseconds. It took us 2 weeks on a supercomputer to run like that small amount of space for that small amount of time. Took us 10 days. And I thought, gosh, how on earth are we ever going to be able to simulate this entire interaction in its totality? And, he said, well, 20 years ago, we couldn't even do this, right? 20 years ago, we had a tough time simulating 3 electrons doing this. And now we can do this. In 20 years, what will they be simulating? And he asked, have you heard of the simulation argument? And thinking about like the concept of simulating ourselves. And the first thing I think you battle with, and what people think about when they think about simulation, the simulation hypothesis is the statement that is statement 3 of the simulation argument, that we're already living in the simulation. And that's something you battle with the most. And this is the idea of simulation theory, like, oh gosh, like, how is it possible that we are living in a simulation? It's the concept of the matrix, maybe in some part, the concept of inception, that like you could fool somebody into thinking that they're in the real world, even when they're in a dream. And so that was my first battle, is like, is that a finite thing to simulate the human being? And I thought, yes, I think that is. I think at some point you have enough computing power that you could have something in a computer that thought it was a sentient being. Then the other difficult piece is battling with the mathematics of the third one, that thinks that, okay, I have agreed to the fact that I think you can simulate a person. And that we are going to, like, as a society, I don't think it, again, this is maybe naive, but I don't think we're not going to do it. Our society has never shied away from like doing something because we first could clone. Remember, it was cloning, right? Like, oh my gosh, should we really clone a lamb? It's like, yeah, by the time we were battling with that, they had already done it. CRISPR,
yeah,
right? Should we really mess with the human genome? You know what? By the time somebody had already done that in a lab, by the time we were questioning it. So we don't seem to shy away from like, should we do it? We say, can we do it?
Right.
So then it reduces to like, then you have to battle with like, okay, so then the likelihood is that you're living in a simulation.
Yeah. Did the first proposition ever appeal to you more, or was it mainly just the third one that was?
Well, I mean, you mean like us going extinct? I mean, to me, that's what it boils down to. So we're biological beings, and we haven't reached it yet, right? So think about that. So basically, then you're saying, great, we're on our path to extinction. Guys, pretty morbid, right? Like if you don't think we're going to stop before we get there, either we're headed for extinction or we're living in a simulation. Those are your two options. It's like, wait, but what? There's no other option. I want to be a real person. Like, I'm making my own decisions. I don't want to be some computer code. But then you basically battle with like, if you're a conscious, sentient, free-willed being, does it make a difference whether you are in a biological carcass or whether you just think you are, and you can choose anything you want in this code. This code is helping you make your free will choices.
I mean, I think if we agree to those three propositions, and that one of them I think it is probably true that one of them has to be true. So then the third one makes the most sense in that case. I could see this leading to some, I mean, like you even mentioned a little bit, like I could see it leading to some serious, like existential, like re-examining of your own life. I mean, this is philosophy, but it seems like a pretty radical, even though it makes sense, it's pretty radical in terms of the effect it could have on you as an individual. Yeah.
I mean, I think some of our follow-up podcasts should consider, okay, if I am living in a simulation, like, how does that change my everyday life? That's certainly one question. And maybe the second question is, can we have brilliant scientists around the world? Can they tell me if I'm living in a simulation? Like, let's forget about what I'm going to do. Like, can you tell me for sure whether I'm living in a simulation? That way I can get that piece out of it. And so are there ways for us to detect this? And, obviously you and I are not the first people to deeply consider this. They have massive symposiums on this. I watched one this morning hosted by Neil deGrasse Tyson and Jim Gates, as I told you about, and a number of other philosophers and Nobel Prize winning physicists, as they discuss, like, is it worth pursuing the fact that we are living in a simulation? And more so, they have more of these symposiums, which means it is becoming more prevalent in the science community. Whereas once it was fringe, and it's just like, Yeah. Okay, great. Sure. Yeah. We're living in a simulation like the Matrix. Now you think, interesting. Should we dedicate research dollars and research time and energy to pursuing this?
Yeah, it is interesting because I would, in future episodes, love to get more into details, like you mentioned at the very beginning, about this self-correcting error code. That sounds fascinating in relation to this, of course. I'd like to know more about that in terms of details and maybe other evidences that can be gleaned from scientific study, I guess, beyond just philosophy.
Yeah.
Wow. Okay, so what an episode. Let's pause there for a moment. Any final things you want to add about simulation theory before we wrap things up here, Lee?
I think, maybe one thing I'll add to this is, you and I, Josh, work with many students, and you would think that running a tutoring company where you're dealing with verbal aspects and I'm dealing with math, the concept of spirituality doesn't come up much. But in thinking about how people budget their time, I think the concept of spirituality, to me, you don't necessarily have to tie to religion. Your concept of spirituality is considering what your place in the universe is. And I think everyone should dedicate time every week to doing that. It doesn't just have to be a Sunday thing. You should dedicate multiple times per week to thinking about your place in the universe. And this, to me, fits in that, right? Like, okay, if I exist only in the state of a computer, does that change how I want to interact with somebody? And fast forward, I don't think so. I mean, I think ultimately you're driven by what you feel, and I don't think, even if we knew definitively, if somebody popped up a browser window and said, Josh, you're living in a simulation, it would be shocking, and you would certainly talk about it for a little bit. But I think ultimately we would sort of we would gravitate back to our natural inclinations. And so I think it's a good thing to consider things like this, even if at the end of it, you're like, no, I'm going to keep living my life, and I don't think the simulation thing is real.
Yeah, I mean, it's certainly intriguing enough that it's interesting enough where you consider it and think about it and see what effect it could have. And I mean, again, that's a part of life itself, as you introduce yourself to at least for me, hopefully, as many new ideas as possible. And then you let them sort of like battle themselves out and see which one comes out on top. And this is certainly an interesting one as well to throw into the equation.
Yeah.
I will say, to end this, if we go back to the friendship paradox, just remember, what are the odds that this sort of theory is correct, or computer simulation theory, versus all the other religious ideas in all of human history up to this point? We got to keep that part in mind. It might be more likely that those ones are correct versus this one, but I am very intrigued by this one as well.
Josh, even more, let's go more meta than that.
Let's do it. Yeah.
Maybe all of those are in the mind. Those are only the ones that we observe and we believe to be true, right? That's our biases, and it's probably much more probable maybe that it's something we haven't even thought of, because we only observe a finite bit of this. Dark matter we haven't done anything on dark matter. Dark matter constitutes the majority of the matter in the universe, and that's just a place where we have no idea what that is. So
yeah, you can't just bring up dark matter at the end of a podcast, because that's also another topic I'd love to talk about. Yeah, that's a weird.
That'll be season 2, Josh. Dark matter will be season 2.
Season 2. Wow. Okay, so simulation. The intro. There'll be more episodes on this as we go along. But yes, Lee, thank you for this wonderful rundown of this. And we'll be doing, as usual, our follow-up live programs, and then after that, a couple episodes. Depending, again, if you have comments or questions, we'd love to hear them, because we want to kind of base the next couple episodes on maybe viewer reaction, as well as discussion that we have about what other main aspects of this theory would be best to sort of pursue. So yes, please, as always, drop a comment in the box below. Smash that like button, even if it doesn't exist, because we're in a simulation. But yes, thank you everyone for watching. Lee, any final words before we sign off for today?
No, just keeping in mind that I think the next one, I think we'll go back to YouTube Live. We'll try to get a big audience for this, just getting as many questions as possible. And again, if you have questions and you don't think you'll be able to tune in for the YouTube Live, send them to us ahead of time, and Josh and I will address them during our follow-up.
Indeed. All right. Well, as always, thanks everybody for watching. Enjoy the rest of your day today. And yeah, go simulation theory.
Yes. Awesome.
Bye, everybody.
Bye.